Hello guys, good afternoon. You are welcome to my YouTube channel, The Explicit Tutorials. As you all know, I'm Dr. Joseph or Mr. Explicit, and we are still discussing work, energy, and power. Alright, we are taking some jump questions on the topic already. So we have about 2 questions on the board that we are to carefully solve together. The first one says, if a body of mass 5 kg is thrown vertically upwards with a velocity u, at what height will the potential energy equal to the kinetic energy? I take it again. If a body of mass 5 kg is thrown vertically upwards with a velocity u, at what height will the potential energy equal to the kinetic energy? So they said at what height? So which means we have to look for the height. At what height will the potential energy equal to the kinetic energy? And of course, I told us in our previous class that potential energy is mgh, right? Potential energy is mgh. The kinetic energy is half mv squared. But now they're using u, right? So which means I will have to be using what? U and not what? V. So from here, they gave us the mass to be 5 kg. If I should slot in 5 here and 5 here, this m's cannot cancel out, which means 5 will go out. So what do I now have? I'll now be having GH is equals what? U squared over what? U squared over 2. So what do I do from here? I will have to what? Cross multiply. If I should cross multiply here, this will multiply this and this multiply this. If this should multiply this, I'll be having 2GH equals U squared times 1 is same thing as what? U squared, right? So I'll divide both sides by what's attached to H, and that is what? 2G. So divide both sides by 2G, alright? Therefore, height becomes U squared over what? 2G. This becomes my final answer. So is the answer there? H equals U squared over what? 2G. So the answer is what? D. It is as easy as that. Okay. Now this is what we have the question 2 of it. They said a load of mass 120 kg is raised vertically through a height of 2 meters in 30 seconds by a machine whose efficiency is 100%. Calculate the power generated by the machine. A load of mass 120 kg is raised vertically through a height of 2 meters in 30 seconds by a machine whose efficiency is 100%. Calculate the power generated by the machine, and we were given G to be 10 meters per second squared. Once you see this value in work, energy, and power, it tells you it is the efficiency. It is what? Efficiency of what? Power. That is what it tells you. Now, in our previous class, I'll rub off this part, please. In our previous class, I did tell you that power is equals power outputs over power inputs, which is Pi times what? 100 over what? 1. And I said that in most cases we tend to be given the power input, but we are not given the power output. Okay, so in this case they are asking us what is the energy generated, or what is the power generated. So this is how it is going to work. And I told you that for you to look for the power output, it is mass times acceleration, but we're not given acceleration, they give us gravity. So we are using gravity times what? Distance over time. Which means whatever I get, I'll place it here. So from the question, mass is 120 kg, gravity is what? 10. Then distance is what? Distance is 2 meters times 2, and time is 30. Alright, time is what? 30. So this will go into this. 3 here 1, 3 into 12 is what? 4. I now have 40 times 2. That will give you what? 80. So it means that the power output becomes what? 80 watts. I take it again. The cell should calculate for the power generated by the machine. We are expected to look for the power output first, so that whatever we get, we'll slot it into it. From what I have solved, I told us that if we are to look for the power output, we are using M times A times S over what? C. In this case, we are giving G as, that is in place of what? A. So we are making use of what? G. The mass is 120, the gravity is 10, then distance is 2, then time is what? Seconds. You know, in JAM and post-UTME, you are not expected to use calculator, so it means that you do everything offhand. So 0 going to 0, I'm left with what? 120 and 2, alright? So 3 into 12 is what? 4. I have what? 40. 40 times this 2, I'll have what? 80. It therefore means that my power output is what? 80 watts. 80 watts. Alright? Efficiency, of course, this is power efficiency. We are giving the efficiency as what? 100. So it means I'll place 100 here. Watts, I got 80 here. Then, of course, I'm looking my power output, I'll make it what? X times 100 over what? 1. If I cross multiply, I'll be having 100x equals 80 times this is what? 8,000. 8,000 divided by what? Divided by 100. So this would go into this. Alright, what do I have left? I'll have that x is equals 2 zeros into 2 zeros, and that is what? 80 watts. So the final answer to this simple question is what? 80 watt. That is what? Option C. I take it again. We were not given the power output. Of course, we are looking for the power and input. For me to get the power output, we are to use the normal procedure, which is this. As long as you've gotten this, slot it into this place. You now have 80. The efficiency was given as what? 100, and of course times 100 over 1, which is the formula. Then from here, you now have that. Of course, you cross multiply. That is this times this is what? 100x. And this times this is what? 8,000. You are looking for x. Divide both sides by what's attached to x, and that is what? 100. So you now divide both sides by 100. 2 zeros will go into 2 zeros, and that is what? 80 watts. So the answer is what? 80 watts. C. Right. So please, if you know you have learned something in today's video, endeavor to subscribe, like, share, and comment. As I've always told us, if you are preparing for 2024 JAM or post-UTME, NECO, WAEC, GCE, nursing exams, endeavor to chat me up on 091 60 11 53 75. Do have a wonderful day.